So on the back side, notice, and this is kind of common on these, if it's like this one's probably a non-calc question, but notice in the directions it says set up the volume, not find the volume. So all we're doing is setting up the integral and just leaving it. We don't actually have to do the rest by hand. We're just setting up our relationship, our integral, and then stopping. So region bounded by y equals x squared, rotating around the line y equals 3, which remember is technically a horizontal line, so that's going to be a dx, a horizontal rotation. So let's kind of think about what those graphs look like. So y equals x squared, that would just be a parabola passing through the origin. And then y equals x would just be a linear function that would basically just sort of intersect the parabola somewhere over in the quadrant 1. So then our area of interest would be this little sort of wedge between those graphs. And we're rotating around the line y equals 3. So we might want to just kind of make sure we sort of know our intersection points so we can kind of know like where we're hitting on the y-axis. So they would both start at 0. Again, this is one you can almost do with mental math. If you just plug in 1 for x, 1 and 1 squared would be the same value. So this would be 1. And then to clarify, if I plug in 1, it's hitting at a height of 1. So this region's ending at 1, 1, which means my axis would actually be sort of up here somewhere. My y equals 3 would be up above this entire region. So we're spinning up around a line that's on top of the graph. So let's go ahead and we already have our sort of limits of integration. So let's figure out our big R and our little r. So remember, big R is the distance between the axis, the purple line, and whatever line is further away from it, which in this case would be the blue line. And remember, I draw my arrow in the order it's going to go in the problem, which is top minus bottom. So in this case, it's going to be axis first, 3, minus the curve, which is x squared. And then that doesn't simplify, so that's my big R. My little r is the distance from the axis to whatever's closer. So in this case, my little r would be axis first on top, minus the function, which is just x. And again, that can't simplify anymore. So now you have all the pieces. So we'd end up with volume. Don't forget, we still need that pi. It'll be the integral from 0 to 1 of big R squared, so 3 minus x squared squared, minus little r squared, and then all dx. And then that is it. That's my final answer. It's set up, but don't solve. Optional, but if you want to, you can always kind of put a bracket around your integrand, which is the stuff inside the integral. You don't have to, but sometimes it's nice to kind of group it. Okay. So on the front side, we tried a vertical one, number 2, where the axis was to the left of the area. The next example is going to be one where the axis is kind of on the right side of the area. So let's try that one real fast. So we're looking for the volume of the region bounded by y equals root x, y equals 0, and x equals 4, going around the line x equals 6, which to clarify is a vertical line, so this is dy. So let's kind of set up our region here. So I've got y equals square root of x kind of our sideways half parabola. Y equals 0 is basically the x-axis, and then x equals 4. So that's going to be sort of somewhere over here. So our region is bounded by root x, y equals 0, and x equals 4. So that guy. The only difference is our axis this time. Our axis is the line x equals 6. So my axis of revolution is out here to the right side of the area. And because the area is not touching it the whole way, we know it's going to be a washer method again. So we now would need to think about a couple pieces. We need to know our limits. We know it's going from 0 to 4 on the x-axis, but remember we need to do this dy. So I need to know where does this area start and begin on the y-axis. So we kind of know the bottom would still be hitting at 0. The top, think about where that would hit. If I plug 4 into the function, the square root of 4 is 2. So that would be hitting at a height of 2. So that's my limits, 0 to 2. Oh, sorry, I kind of skipped over it, but this is another one that's a set up but don't solve. So once we set it up, we're just finished. So my big R is going to be the distance between the axis and whatever function's further from the axis. So my big R, and notice the order matters. This time, because the axis is to the right of the area, it's going to be axis first minus graph. Oh, we also need to be a little careful, just like the one on the front. That equation is currently in y equals root x form. I need to rearrange it so x is by itself, which we would just do by squaring both sides. So rearrange, that would actually be x equals y squared. So it would be 6 minus y squared would actually be my big R. So then my little r is going to be the distance from the axis on the right to the closer one on the left. So in this case, it'll be axis first, 6, minus the red line, which is just a constant 4. And that one, because that combines, I could go ahead and write just little r equals 2. So little r is just a constant. So now we have all of our pieces. So overall setup would be volume equals pi integral from 0 to 2 of big R squared, 6 minus y squared, take away 2 squared, and then all dy. And again, set up but don't solve, so that's it. That would be the answer. So let's try one last one. This is one that we're actually going to evaluate because it is calc aloud, so we'll actually finish it on the calculator. Even though it just says set up, because it's calc aloud, let's go ahead and actually evaluate. So we'll actually get a number answer on this one because we can. It's pretty quick once we set it up. Alright, so we're looking for the region bounded by y equals 6 minus 2x minus x squared and x plus 6 revolving around the line y equals 3, which remember, that is actually a horizontal line, so this is going to be a dx. So, I don't know exactly, I know we have a parabola of some kind, and we have a linear function. The good news is it's calc aloud, so we can actually go ahead and graph those. So I'm going to go ahead and put the blue guy under y1, and the green one under y2. So 6 minus 2x minus x squared, and under y2, x plus 6. And I'm going to start with just a zoom standard and see if that gives me a decent picture. So that's actually looking pretty good, actually. So what I'm seeing is kind of got my upside down parabola. So we're going like that. I got my linear equation kind of cutting up through it like that-ish. I guess it's hitting sort of on the y-axis, but a little more like that. So then we're going around the line y equals 3. If you'd like to actually visualize that in your calculator, under y3, you could just put the number 3. And then we'll be able to kind of see that y equals 3 actually kind of cuts right across the bottom of the shape. So that y equals 3 axis will kind of touch the lower part of the shape. So then my area we're interested in would be this little sort of wedge under the parabola and above the linear equation. We're going dx, so then the only other thing we might want to make sure we have on the graph before we leave it is we want to know the x-coordinates of those intersection points. So it looks like the right one I'm assuming is 0, but you could always double check doing an intersect. If you do second trace 5, just make sure you're kind of toggling between the linear one and the parabola using the up and down arrow. So just to clarify, mine's showing like 3.5 e negative 15. That basically means 0. It's like 14 zeros and a 3. So that point is 0. And then my other intersection, again, make sure you're toggling between the parabola and the linear equation, is negative 3. So that's my limits, negative 3 to 0. So now let's kind of set up our pieces. So this time, it'll be a little bit more. Do we do one on the front side? Actually, we haven't done one yet like this. The axis is underneath the area. So when we're setting up the big R and the little r, we want to keep track of that order. So the big R is actually going to be the distance from the curve that's farther away down to the axis. So my big R is actually going to be the parabola, 6 minus 2x minus x squared first, because it's on top, minus the axis, which is 3 second. And if we sort of maybe simplify and combine like terms, we could basically reorder that as negative x squared minus 2x plus 3, if we just kind of reordered it in a standard form and combined like terms. My little r is going to be the distance from the closer function down to the axis. Again, starting at the function because it's on top. So little r is going to be the linear function, x plus 6, minus the axis, which is on the bottom, 3. And again, if we combine like terms, we could simplify that into just x plus 3. So my final setup on that guy then would be volume equals pi integral from negative 3 to 0 of big R squared, which would be negative x squared minus 2x plus 3 parentheses squared, take away x plus 3 squared, all dx. So that would be the setup. And then because we have a calculator, we could go ahead and actually just evaluate that to see if that works out. I'm going to go ahead and just hand type them because we did all the minus 3's and I don't want to mess up my y1 and y2. So I'm just going to kind of type it by hand. So pi math 9 negative 3 to 0. And then my first parentheses will be the negative x squared minus 2x plus 3, close parentheses squared, take away x plus 3, close parentheses squared, dx. I'm getting 67.858. So again, kind of similar to note card 62 and 63. The main difference is just that idea of we're adding in that axis. That axis needs to be involved somehow in my big R and little r. Whether the axis is going in front minus the function, or the function minus the axis. That'll depend on whether the axis is above or below the region. So just to clarify, the homework on this one is going to be calc aloud, but what I do want to see is the setup. So I'm basically, on the homework, I'm looking for the setup of the integral with everything written out, and then you can jump to the answer in the calculator. So each one's worth kind of like half a point. So good luck. I hope it goes okay, and I'll see you guys tomorrow.